okay with me erasing the middle board? All right. Well, I think the conclusion of the mean value theorem simply says that f prime of c is equal to my f of b minus my f of a all over my b minus a. It's just, you guys, when you look at my function f, what's its derivative? It's just 1 over x. So I think f prime of c is just 1 over c. Is equal to my natural log of 4 minus my natural log of 2 all over 2. I think at this stage of the game, the question is, can I solve for c? Piece of cake. Does that tell me c is equal to 2 over the difference in these two logs? Or shall I see? C is equal to 2 over, I don't know what that is. Is that just a natural log of 2? You guys are so quiet.
So confused.
Are you really, David?
Yes.
I apologize. You're confused where?
Well, it's just all kind of new, just take it all and shove it down my neck kind of deal.
I try to be that violent. By the way, you guys, I might have made a mistake. Can I check this real quick? The natural log of 1 is 0. Natural log of 2, because the curvature of that log function, is just a little bigger than 1. 2 divided by something a little bit bigger than 1 is going to be...
A little bit less than 1?
Well, I think a little bit less than...
Oh, bigger. A little bit less than 1.
Yeah, I think it's going to be a little bigger than 2. Because the natural log of 2 is a little bigger than 0, isn't it? Did I say that correctly? The natural log of 1 is 0, so the natural log of 2 is a little bit bigger than 0, but less than 1. I think 2 divided by something between 0 and 1 is going to be somewhere between 2 and 4. It's going to be slightly bigger than 2.
It's 2.88.
Oh, I was correct. 2.88. Let me just double check on top of my head.
Oh, wait, on the calculator.
Do a linear approximation of this.
Oh, absolutely. So here too, you guys, the conclusion of the mean value theorem says there must exist a c for which the slope of the tangent line there is going to be equal to the slope of the tangent line. I misspoke already. There's got to exist a c for which the slope of the tangent line there is got to be equal to the slope of the secant line passing through the two endpoints, which is computed as such. It's just that in this one particular example, I think f prime of c is going to be this. Well, David, check this out. If f of x is this, isn't f prime of x clearly negative 1 over x plus 1 squared?
Yes.
Okay. And I just simply value of x is equal to c.
C.
And on the right-hand side, I have no idea what I get. Is that a 1/4 minus 1/3 all over 1? So my negative 1 over c plus 1 squared is going to be, yikes, is that a negative 1 over 12?
I got you.
Oh, it's okay, I'm there.
Okay.
But the reciprocating side, c plus 1 squared, is equal to 12. Or better yet, c plus 1 is equal to plus or minus 2 root 3. Or best yet, c is equal to negative 1 plus or minus 2 root 3. Oh shoot, you guys, I just ran amok again with all my algebra, and I lost track of what the heck I'm doing. What did I just find?
C.
How many?
2.
How many?
We're going to discount 1.
1.
1.
Only one that lives strictly between, I've lost it, strictly between 2 and 3. I think my choice for C is going to be negative 1 plus 2 root 3. That's the only one that lives between the interval, between 2 and 3 cells. Happy?
2.46.
Ah, I was right again. Jeepers.
What? Oh, it says peak?
Weak.
That was a sense.
That looked like...
No, that was obviously a K, you guys. That was a
Okay.
sense.
Yeah, it looked like a cent sign to me, too. Alright.
What does it say?
Do you guys think we can evaluate the limit? How? Never heard of that.
There's 2/3, right?
Where'd you get that?
Look at the powers the same, so it's the coefficients in front of them.
Oh, that sounds like magic.
Sounds like right.
That's the right answer. It is the right answer, you're right.
Five is negligible.
Yeah,
You know, that's a good point
the
as well.
infinity at the top is twice as big, or no, it's the infinity at the
How
top.
did I train you this semester to evaluate this limit?
You multiply it by 1 over
Top and
x
bottom by
squared.
1 over
Yeah, x squared.
x squared.
But
right.
it's like the
Remember
long
one
way.
way.
The hospital.
Or you can just memorize it.
Don't have to worry about, memorize it. The negative things that really involve an x squared every time in this case. You guys, I think if I just multiply top and bottom by 1 over x squared, I just get this limit. It's just that now you guys can relax, kick your feet up, take a peek at the second term downstairs, and identify what the heck happens to 5 over x squared as x increases up down this piece of cake. And now I'm merely left with a constant 2/3. Again, I'm just pushing you a little bit to justify what's really going on. Are you there?
Yeah.
I think, however, when it comes to this limit, life's a little more difficult. Whoops, sorry, I missed something. Only in the sense that, shoot, this isn't the rational expression. This is not the ratio of two polynomials. I guess I can't play the same game. Actually, maybe I can say this. I'm stuck. I can't answer the question. Because I think the tools I gave you at the beginning of the semester are so darn weak. They only really truly work when I had ratios of polynomials, which themselves are just rational expressions. I need to get out of this trap. Can I just show you what it is and not apply it yet?
Yes.
Here's what the technique's going to be. Assuming I've got continuity, differentiability, when you and I take the limit as x approaches, say, how about an a, but it could be infinity or negative infinity. And I've got the ratio of two functions. This ends up being nothing more than the limit as x approaches a of the ratio of the rates of change of those two functions. And a lot of times in looking at the ratio of the rate of change of functions, it becomes a heck of a lot easier for me to value these limits. And that's exactly going to be the case in this particular example. And this is so important, I'm going to give it a name. Yeah, you guys know the penalty for mispronouncing the French, right? Don't do that.
They're going to.
The hospital? Are we at that one?
I'm very good.
Okay.
Don't do that.
You want to pass the class?
Remember, I signed a letter grade your name at the end of the semester. L'Hôpital's rule? Actually, I shouldn't even be so stubborn about this, because technically speaking, the French don't use approximate apostrophes like that, but it could be Le Rue de l'Hôpital. So you guys, that's where we're going with this. I've got so many case scenarios to apply here. I've got a lot of different cases. For now, in the examples I've given you so far, notice how in each one of these two limits, when I try to evaluate this expression as x increased upbound, check out what happens. This increased upbound and this increased upbound. And I sometimes refer to this as one of my standard indeterminate forms for a limit. And when I get an infinity over infinity situation, it's often the case I will apply L'Hôpital's rule, unless it's something easy to do. No homework on this, I promise. I'll deal with it tomorrow. Did it really?
I don't think it's actually I don't think it's actually spelled hospital though. Last time I guess I just did that this one.
No, it isn't. It's spelled H-O with a thing on top and then P-I-T-A-L.
You know what? I've seen it both ways. I've seen it spelled both
Yeah,
ways.
because they don't use the S.
Yeah, at the end, of course not.
Yeah. Well, no. I meant the S inside of it after that.
Yeah, I've seen it spelled a couple of ways.
People can't.